Alright, so as a continuance from the last video, we want to write a polynomial function of least degree given these zeros. We're still doing the same thing, basically meaning we're still using the conjugate root theorem. So I have to find the opposite roots. So I have a 3i here, so we know that the opposite root is negative 3i, the conjugate is negative 3i. And then I have 1 plus square root of 2. So the conjugate of that is 1 minus the square root of 2. So I have 4 roots, okay? Let me write this just kind of horizontally here. So I have 4 roots, negative 3i and 1 minus root 2. So again, I want to use parentheses and kind of put them back in. So I'm going to get x minus 3i from this one. I'm going to put this one next because it's the opposite of the 3i. So I get x plus 3i. Then for the 1 plus square root of 2, okay, I get x minus 1 plus root 2. And then for the 1 minus square root of 2, okay, right here, I get x minus 1 minus square root of 2. So you can see that you still have the minuses in there, and we're just doing the opposites of them. So I'm going to leave these the same, the x minus 3i and the x plus 3i, those have to remain the same. But then here with the distributive property, this actually turns to x minus 1 minus root 2. And then this one also changes to x minus 1 plus root 2. And then of course you have your x minus 3i and then x plus 3i out front. So I'm going to then multiply these two, the first two binomials, the 3i's. And because of the shortcut that we've been doing, I get x squared. And then that's really minus 9i squared. But because of the I squared means negative 1, we get x squared plus 9. Okay? Then I have these two trinomials. So I have this trinomial and I have this trinomial here. And I need to multiply those together. So there's two different ways to do so. One way is the box. So let's show that way here. Let me erase some things here. Okay. So I'm going to put x minus 1 minus 2i, or minus x minus 1 minus root 2 on top. I'm going to put x minus 1 plus root 2 on the side. And then I have my 3 by 3 box. So I get x squared minus x root 2, negative x 1 positive root 2. I get x root 2. I get negative root 2. And because I'm multiplying the square roots, they're the same numbers inside, I get negative 2. So now I can cancel the x root 2 with the negative x root 2. The negative root 2 and the positive root 2 are gone. So what's left is x squared minus 2x minus 1. Because x squared goes first, the negative x terms become negative 2x, and then the 1 minus 2 becomes a negative 1. So those two trinomials multiply together to get x squared minus 2x minus 1. Now some of you might be asking, well, that's a lot of work. Is there something that I can do maybe quicker? Yes, there actually is. So what I can do is I can group the x minus 1's together inside the original set of parentheses. And it'll be x minus 1 squared. And then I'm still actually multiplying the root 2's and the negative root 2 together. When I do that, I get negative 2. Okay? So, then I multiply x minus 1 squared. This is actually x squared minus 2x plus 1. And then I put down the negative 2 that I didn't touch. And then when I actually combine those, I get x squared minus 2x minus 1. So I get the same answer here or here. You can use whatever, I don't care. It's up to you what you want to do there. But I'm not done yet. I have my original x squared plus 9, and I have my x squared minus 2x minus 1 from the box or from the other method that I showed. So I am going to now multiply those out in a box. Okay, so let's do that. So I get x squared minus 2x minus 1, x squared and 9. So I get x to the 4 minus 2x to the 3 minus x squared. 9x squared is here. I get negative 18x and negative 9. So again, now you can see that the diagonals don't actually add together. There's terms that do add together, but not the diagonals. That negative x squared and that 9x squared are the only two things that I can actually add together and combine. Everything else has to be written exactly the way it is. So let's rewrite it. So I got p of x, polynomial of x equals x to the 4 minus 2x to the 3 plus 8x squared minus 18x minus 9. And that is your answer for that problem. Again, pause the video, go through and make sure you understand how to do this. Write stuff down, write your notes, okay? And then ask questions in class and so on. Okay, so that's number 7. Let's go to the last one here, which is number 8. We're just going to do 2 examples here. And I don't have any i's, I don't have any imaginary numbers, so that's good. But I do have square roots, so that means they're irrational. So that means I have opposite square roots as well, conjugates of those also. So this would be negative 3 minus 2 root 2. And this one would be negative root 7. So I'm going to I'll put the root 7s in parentheses first because those are a little easier. That's x minus root 7 and then x plus root 7. Okay? The tricky part is going to be here, which that's what's going to happen. So remember, I get x minus, and then I have a negative 3 plus 2 root 2. And then I also have an x minus, then the negative 3 minus 2 root 2. So this one here, because of the distribution property, it actually turns into x plus 3 minus 2 root 2. And then the bottom one turns into also x plus 3, but then a positive 2 root 2. Okay? So now I'm going to multiply some things. So I have 4 nomials. So I have a binomial, then I have a trinomial and a trinomial. And those are 4. I have to multiply them all together. Remember, I said to always use probably the conjugates to deal with them first. Makes your life a little easier. So when I multiply x minus square root of 7 and then x plus the square root of 7, I end up getting x squared minus 7. Because of the way multiplications with square roots work. That's the easy one. The hard one is going to be these two here. So I'm just going to erase a little bit. I'm going to leave x squared minus 7. Actually, I'll move it. So x squared minus 7 over here. So I'm going to do the box first, and then we'll do everything else after. So I get x plus 3 minus 2 root 2. I get x plus 3 and then plus 2 root 2. And then I have my 3 by 3 box. I get x squared, 3x, negative 2x root 2. I get 3x, 9, and negative 6 root 2. When I multiply a number, not without a root, with a number with a root, all I do is multiply the numbers outside together. So 3 times the negative 2 becomes negative 6, and the root 2 just stays there. Then I'm multiplying the last row, which would be 2x root 2. Then I would again do the same thing, and I would get 6 root 2. Again, 2 times 3 is 6, and then root 2. And then here comes a little bit of another tricky part. If I just multiply root 2 times root 2, that would give me 2. Okay? So root 2 times root 2 is 2. But then I have the numbers out front. 2 times negative 2 is negative 4. And then I actually have to multiply those together, so I get negative 8. So 2 root 2 times negative 2 root 2 gives me negative 8 when I multiply it together. You could also use a calculator, and if you type it in correctly with parentheses, you'll get negative 8 also. Now what things cancel? Well, 2x root 2 and negative 2x root 2 are gone. 6 root 2, negative 6 root 2 are also thrown out the window. What is left? I'm left with x squared plus 6x plus 1. Because 3x and 3x make 6x, 9 minus 8 gives me 1. So I take that, x squared plus 6x plus 1, and I'm going to multiply it with what I had originally, which is x squared minus 7. So x squared plus 6x plus 1, and I'm going to do another box. I got x squared plus 6x plus 1, and then I got x squared minus 7. Multiply x to the 4, 6x to the 3, x squared, negative 7x squared, negative 42x, and negative 7. Then I can rewrite it. Again, remember, most of the diagonals sometimes don't work. Diagonal and diagonal, those two do. Okay, not 6x to the third. So my answer is going to be P of x equals x to the 4 plus 6x to the third minus 6x squared minus 42x minus 7. And there you go.